Modified DSR protocol using link prediction algorithm for reliable ad hoc network. Abstract: the MANET, mobile ad hoc network, is a self-configured, self-organized, infrastructure-less network, and it consists of nodes which are mobile in nature, and each node can transfer the data packets with each other over either radio or infrared. Some devices like laptop computers and personal digital assistants that can able to communicate with each other directly can be examples of nodes in the ad hoc network. In MANET, each device is free to move independently in any direction and will change the links to other devices frequently. Each node must forward the data packets until it reach at destination. MANET have variety range of applications like military battlefield, disaster area, commercial use, sensor networks, etc. In those places where a temporary network architecture is required in quick interval of time for the transmission of data, the ad hoc network uses no centralized authority. So, there will be no collapse in the network. Mobile nodes moves away from the transmission range. In this type of network, nodes must be able to enter/leave the network according to their wish. Since MANET have limited transmission range of nodes, so multiple hops are required for the transmission of the data packets. We have analyzed various routing protocols like DSR, dynamic source routing, DSDV, destination sequence distance vector, AODV, Ad-hoc On-demand Distance Vector. The DSR protocol have more restrictions as comparison with other routing protocols like DSDV and AODV routing protocols. The link break is one of the major limitation in DSR protocol. The link break occurs simultaneously in DSR protocol because MANET there is a frequent change of topology which cause continuous mobility of nodes results link break, so we have proposed a link prediction algorithm from which DSR protocol link break issue can be resolved. The parameters like energy consumption, throughput, end-to-end delay has been evaluated in Network Simulator 2, NS2, simulation software. Keywords: DSR, DSDV, AODV, link prediction, topology. Introduction. MANET, mobile ad hoc network, is a type of self-organized, self-configured, infrastructure-less network which are connected wirelessly. This network is ad hoc because it doesn't depend on a pre-existing infrastructure like access point in wireless network or routers in wired network. An ad hoc network is a self-organizing multi-hop wireless network that does not rely on fixed networks or predefined networking. In this network architecture, each node is used to forward the data packets to other nodes. So, transmission of data depends on network connectivity and the routing algorithm. Since MANET can reconfigure itself and frequent change of topology makes mobility of the nodes. Wireless mobile ad hoc network are self-configuring, dynamic networks in which nodes are free to move. The power consumption in nodes and frequent link break due to continuous mobility of nodes are major limiting factors in it. Consumption of power is always a topic of interest for researchers because in this type of network nodes has very limited amount of battery. When these networks deploy, then battery replacement is not possible, and due to continuous mobility of nodes there is link break occurs, and in MANET for the reliable data transmission proper link management is the most required parameter. The routing protocol is the most important topic, and DSR, dynamic source routing, DSDV, destination sequence distance vector, AODV, ad-hoc on-demand distance vector, are those protocol which are frequently used in MANET. We have analyzed various protocols like DSR, DSDV, AODV routing protocols for, and DSR protocol has more restrictions compared with DSDV and AODV routing protocols. The major limitation of DSR protocol is flooding and link break due to frequent change of topology. So, we have proposed an algorithm from which proper link management is done, and it make the network architecture of the DSR protocol more reliable, and the proposed algorithm will have proper link management to make the network architecture of the DSR protocol more efficient than normal DSR protocol. 2. Methodology. In MANET, mobile ad hoc network, due to continuous mobility of nodes there is a frequent change in the topology, and those mobility of nodes cause link break. In traditional routing algorithms, when the link break occurs, then new route discovered for the transmission of data packets, and that methodology results too much delay and so much costly, and ultimately the QoS, quality of service, of the network will be affected. So, we have proposed a methodology which can able to predict the time at which the link will break. So, we have proposed an algorithm to predict the time after which the active link will break, termed as Link Prediction Algorithm 7. The link prediction algorithm work on the basis power of the signal received by the node's data packets and approximation of time, and this works by approximating the time at which power of signal strength drops below the threshold power. When threshold power of the signal strength drops below the threshold level, then it indicates that two nodes separating from each other's transmission range. So, when that signal power falls below certain level, then it will alert the source that the link might break. So, source either find an alternative route in advance or it will repair the link. We have taken 3 consecutive power of signal which is received by data packets received by earlier node are used to predict the link using Newton divided difference method. 3 simulation and results. A. Energy consumption. In modified DSR protocol based on link prediction, the energy consumption parameter has been analyzed in AODV, DSR, and DSDV routing protocols. Table 1 shows the analyzed results in tabular form and Figure 1 shows the results in graphical form. In modified DSR protocol based on link prediction, the average throughput analysis parameter has been analyzed in AODV, DSR, and DSDV routing protocols. Table 2 shows the analyzed results in tabular form and Figure 2 shows the results in graphical form. Table 2, average throughput analysis. C. End-to-end delay analysis. In modified DSR protocol based on link prediction, the end-to-end analysis parameter has also been analyzed in DSR, AODV, and DSDV routing protocols. Table 3 shows the analyzed results in tabular form and Figure 3 shows the results in graphical form. V. Conclusion. The modification in normal DSR protocol shows good performance in end-to-end delay and throughput as we compared with DSR, AODV, DSDV, and modified DSR protocols. The simulation result shows that the proposed approach shows better performance in the transmission of data packets from source to destination. The proposed approach link prediction made the link of the network architecture more reliable. A lots of future scope is available for this model we have discussed here, so we can make some more modification in this protocol to make it much more effective. Further, these modifications which are discussed can be implemented in other routing protocols like DSDV and AODV protocols for making these routing protocols much more effective.